Okay, problem set number 2 for the chiral center problems. Let's start with this one up here in the corner. Okay, so let's assign our priorities. That'll be 1. Carbon double bond takes priority over this carbon single bond over here. So this one right here is going to be 2. I don't really like this purple marker. Whatever. Okay, so let's see here. Bring it around town. Okay, and that looks like it is counterclockwise, S. Okay, let's do this one right here. All right, so this will be 1. These are equal on both sides, so this one actually is a surprise. See, I knew I didn't like this marker. It's not very bright. No chiral, it's an R, center on this one right here. All right, so let's see, get rid of that. Next one down here, let's see, what's gonna take priority? When you're doing problems like this and you're not sure, it's easy to draw, or you should draw out the chain so you kind of know what each carbon's connected to. So this carbon down here, the C represents this carbon, is attached to, let's see, hydrogen, and going up there, another carbon. Okay, and then this one, same thing. I should have drawn it further upstream. Give me a second. There we go. Carbon. Okay, this one is attached to a hydrogen, and then another carbon downstream. There we go. This just makes it easier if you just draw what everything kind of is when you have carbon chains, so you know better priority. Okay. Now this one over here, same thing. Carbon, hydrogen, carbon, hydrogen, carbon. Okay, and the more you do these, the better you'll get. You can just eyeball it. This is just in case you didn't know how to do this. Okay. Oh, don't forget about this one. I'm just gonna write CH3. Okay, so looking at this one, this is bigger right here. Carbon has more carbons. 1, 2, 3, 4. 1, 2, 3. So this one has, I guess, a higher atomic number overall if you add them together. So this side right here is going to be 1. You know what? I'll use a different marker for this. 1. Okay. This side over here with its 3 carbons, still more than that little carbon down there. So this side is going to be 2. And this one right here is left to be 3 because we know that hydrogen is 4. Okay, hopefully that made sense. So just heavier ones get the higher priority. Heavier chains. There we go. Awesome. So this is going, let's see what direction. Oh, counterclockwise. So S. Nice. Okay, next one right here. Let's see what we got going on. Who is gonna get number 1? Well, this carbon has an oxygen attached to it, so let's make that one number 1. This one has a whole chain behind it. We'll make that one number 2. This one right here. So this one will be left as number 3. And again, number 4 hydrogen. So, let's see here. 1 to 2 to 3, back around. This is gonna be R, clockwise. All right, this problem down here in the corner. As you can see, our hydrogen is not either the dashed line or the wedge. So there's a different way to do these problems, or technique. I mean, they're all kind of done the same way. So what we're gonna do is we're gonna swap the hydrogen. Swap hydrogen, okay? With the dash. Remember, because the dash is, if you're thinking about it in a 3-dimensional way, the dash is going to be where you want to hold it. So you want the hydrogen to be in the very back. Notice how the hydrogen on all of these is in the very back. Okay, so swap the hydrogen with the dash. What does that mean? Well, maybe if I write it down, it'll make more sense. Mirror image. Okay. Let's see, but the dash and wedge do not become mirror image. They are still drawn as they are shown right here. So FCH3. Okie dokie. Well, that's not right. Hold on. Sorry about that. Okay, so there. I'm flipping this. These guys are being flipped on this one. So there we go. That looks better. Awesome. Okay, so now let's assign the groups. Number 1, number 2, number 3, and number 4. Now we can go this way. So you'll see that this is S. However, we're not done yet. So that's S when these guys are flipped. In order to get the answer, you have to flip chiral center. Answer. So how when you flip S, what does it become? R. Ta-da! So the chirality is determined with the swap right here, okay? So just real quick, I'm going to reiterate. The hydrogen cannot be back right here on this regular plane. It has to be on the dashed line. So when you have the hydrogen on the dashed line, you determine the chirality here, and whatever you get, flip the answer, and that is the actual answer. Okay? Sweet. All right, hopefully this made sense.